Hello world, Jussi here. Today I would like to show you a little demo on variable inspection and debugging in Editor or Edide. I'm not quite sure what to call this thing yet. But Editor is the working name for this code editor I've been working. And yeah, to get started, let's look at this module here. So here we have some code on the left side, and then we have some result of that code being executed on the right side. In this case, it's a nice little animation. And how this works, or what's the biggest difference in this editor from most typical code editors, is that it's reactive in a way. I'm not quite sure what word to use, but what it does is it compiles all the time. So every time I make some change in the code, it will immediately get compiled, executed, and I will immediately see the result in there. So let's go and dig into this code. So here let's just take any random variable. Let's pick that one and let's change it. So if I'll change it, you can immediately see that there's something happening on the right side. I can either type it by pressing, let's say, 9, which made it drop down, or I can use this kind of quick key shortcut to changing numbers simply by pressing up or down. And the nice thing about this kind of code editor is that when we're coding, even if we don't really know what the code is doing, what the part of the code that we're editing is doing, so let's say we jump into this module and I've never seen it before, I don't know what it does, I can read through the code and I can try to build the model in my head of what it does, or I can just change the variables. And because I get so fast feedback on changing the variables, I will kind of get an intuitive feeling of what the code is doing, even if I don't understand it line by line, character by character. But this is a kind of short intro on what this editor thing is, but today I would like to talk more about the inspection and debugging in this editor. So maybe let's just skip this module for now and let's take something completely empty, something new. So it's editor like any other. We type some variables, we give some values to them, but when we do that, we can. So typically when you work on some coding project, what you do is you type your code in the text editor, then you press save, then you go to your browser and refresh it, when you're doing web development anyway. And you have kind of these two different environments. One environment where you're coding and the other one where you are testing it and running it. But here we have all of it in the same thing, same program. And the upside of this is that we can inspect it on live. So once I created this new variable, I can go and inspect it. I press the variable and it will get highlighted, and then I will see the current value of the highlighted variable up there. Well, that's not a surprise. 234 is 234, but I can do some calculations in here. I can't type apparently the correct characters. No, what's happening? Why can't I say? Oh, okay, now it's a plus, nice. So I'll do something a bit more complicated and then I will see the result in here. Nice, okay. What else? So we can do numbers, we can do strings. And something you will notice in here is that we have it in different color. So we have the number being blue and we have the string being yellow. This is typical for code editors. You have some kind of highlighting, and typically they are able to highlight for you the number when it's an actual number, and the string when it's an actual string. But when you have variables that is a number or a string, they aren't really able to do that typically. But here, when we're doing this live, we have this system that always inspects the variables and it will show them on different colors based on their types. So you can use the the color of the variables here to do your debugging. You don't even need to click it, and you can kind of get some information from the variable just by that. So for example, let's say I want to say document dot query selector, but it's a long and hard word, so maybe I make a typo and I miss the E in here, but I don't notice that, and I keep doing stuff and I get an error. But even before I type the rest of it, I can see that the query selector is purple, and purple is a color that is given to type undefined. So if I type it correctly and I say selector with E, I will get it orange, and orange is a color for functions. So we can kind of see immediately from the code, even if when we type it wrongly, it doesn't throw error because JavaScript allows us to access non-existent items, and then it just returns undefined. It doesn't throw an error. But we can see immediately from the editor that we have made a typo because of the color. So let's just take a short glance in here, tutorial types. So here we can see all the types available, or all the colors of the types. So if we have null or undefined, they will become purple. Booleans and numbers are blue. I have like restricted the number of colors to keep things not too like rainbowy, so it can be easier. Booleans and numbers are kind of typically used in relatively similar fashion. So in some programming languages, you don't even have booleans. You only have zeros indicating false, and you have 1 indicating true, or any number above 0 indicating true. So this is kind of simplification here. Then we have arrays that are, what is cyan? What is the name of this color? Yeah, anyways, something between green and blue. And then we have objects for green, strings for yellow, and functions for orange. Then we will have the typical highlighting that you will see in many code editors. That is for the special what are they called? Operators, special operators in the language that will be completely red. And you can kind of see some similarity here. So you have function, which is reddish, because function is quite similar in a way semantically than the operators. So, you know, it's something that does some actions, executes some code. And then you have this white one here. So JavaScript is weakly, it is not typed language, so statically typed, so you can make variables that don't have any types. And we can have some parts of code, say functions, that takes arguments, and if the function hasn't been executed, we don't know the type of the variable in it, so it will be shown as white. Okay, let's get back to the test here. So let's select body, and let's put it in the body variable, and then we can inspect the body, and here we can see all the information from the body. And you can see here this strange looking character, and what this means is it indicates that this property after it has been received from the prototype of the object. So we are looking at this body object, and the body object has these 4 properties directly in it, and then it has this amount of properties in its prototype, and then after that we will get 2 characters of this, which means that it's the prototype of the prototype, and then we'll have more properties in there, and even more properties in the prototype of the prototype of the prototype, because, you know, it's a DOM object, and DOM objects have quite deep inheritance hierarchy. Okay. Another thing to notice here is we have this red thing pointing the error, we have the yellow thing pointing the spot where the inspector is set. So typically it will be at the point where we have our coding done. So when we are coding this row, the inspector will be set at the same line. But once we have the error here, that kind of changes things, and then it will end up being Oh, no, it's not an error. Well, then it will be thrown at the beginning of the module, but that doesn't really make that big difference, because both the first line and this line, they are in the same scope within the module. But when it does make a difference is when we define the function. So let's say some function, and we do it like this. And now we have some variable here, but we can see the some function becoming orange, but we can't see the type of this variable because it's never executed. This part of the code is never executed, so it won't be set and we can't inspect it. And now, even if we do the inspection in here, and now we have run the code, but if I click here, it will still be undefined, because even though we have run the code, our inspector is on the upper scope. So it's in the module scope, but it's not inside this function. So even if we have run the code and basically this value has been set, our inspector is at the wrong place to be able to see that code. So what we can do is we can make some changes here in the code, and then the inspector, well, actually there's a slide bug also in there. But if we have something more here written, and then I will make a change in here, then the inspector will be at the right position. It will be inside this code, and it will be able to detect the variable in here. So let's make a bit more better example to show how this works. So let's make some function 2, and then let's make some more variables in here. Let's make strings, and maybe another number, and maybe here another string. Okay, so now if I jump around and make change in here, or rather, let's not make a change by so when we change the code, when we type something, the inspector will jump at this position. But there's another way to change this position of the inspector. So if I put my cursor in here and I press Ctrl R or Command R on Mac, it will set the inspector in here. And another thing it will do is it will refresh all the variables in here. So sometimes if I'll do this and I set some variable in here, you will notice that even though this has been set, it will turn blue only once I click it. So when I'm editing the code, it doesn't do a full refresh on all the variables that have already been set before, simply because of performance issues. So it can take some time to inspect all the variables in the whole module, so it won't do that while we are coding. But if I do press Ctrl R, it will refresh all the variables. So actually we're using some of the same variables. So here's another feature that you will see. Once I click a variable, I will see all the other spots of the same variable highlighted elsewhere. So actually this is not a local variable with this function, this is already defined here, so it's a kind of global or module function, so global to this module. So let's change some of these to make sure that we only have it defined in here and it actually is a local variable. So now, if we do here and press Ctrl R, there is an error. Oh, it's not an error, we're just not simply calling this function. So let's call this function, and let's do that again. So I press Ctrl R, and you will see all the variables in here highlighted, because now this function has been executed. We have the inspector inside the function, and we press Ctrl R, so the whole editor is refreshed. The variable colors are refreshed, so we will see. We go here, we press Ctrl R, and then we'll see the colors updated here. Okay, so far so good. So let's do something a bit more complicated. So let's say we make a loop in here for I in 0 to 10, and let's say result is I plus I, or rather let's say 3 times I. So now we have a variable here, and the question is that what is it and how do we inspect it? So we can do the same thing. We can press Control, we can put the inspector in here, press Control R. Let's do it here. Like, yeah. So we are developing a CoffeeScript. We need to do CoffeeScript source mapping to actually put the inspector in the right position. And as we already saw here before, it doesn't always work perfectly. But if we press it here, oh, sorry. Yep. If we press it here, then now we have the inspector inside this function. So it will be able to see all the variables inside here. So we can see what is 3 times I. Well, 3 times I is 30. So this part of the code has been run 10 times. On the last value it will be I will be 10 plus 10 plus 10, so it will be 30. But this isn't really that useful, helpful. Like, we can see the last value of it, but we can't see all the values between. So if we have looping functions, iterative functions, it would be good to have some kind of way of inspecting all the variables in it. Well, one way to do this, quite typical in coding, is logging it. So we can say console log I, and we will get a console, and the console will show us all the different values here. But you know, changing code just simply to make be able to do this debugging is kind of not that easy and fast way of doing debugging. And then once we've done it, we often forget to remove this part of the code, so it will start living there. So in here, in editor, we have a bit more easier, simpler way to do it. So if we highlight 3 times .I, and then we do the same thing, so we press the Ctrl R as we did before, but now when we have some variable that is being inspected, we can also see the variable I in here. We press Ctrl R, and it will do the same thing for us automatically. So instead of typing the console.log, we can simply do it for any variable in here by highlighting it and pressing Ctrl R. Well, in here it's not that interesting because we're simply inspecting one variable, and we can also do it from here. But here, where we have multiple, the variable being changed multiple times on single run, we can see all the different variables. So we can see all the variables from index 0 to 10 being changed over time. Let's take a quick look at another module. So let's say JSON HTML. So this is a module that can be used to print HTML from JSON. So you can type the HTML in JSON format, and it will transfer it to a proper HTML, or HTML nodes, DOM nodes to be exact. And what we have here is a transpile function, and this transpile function is an iterative function, so it calls itself. And not only does it call itself, it has pretty vague parameter names here. So it has a parameter like value or val. So when we start reading this code, it can take a long time to understand all the possible values that this val could have, or what exactly is it that this val does. But with this fast console locking technique, we simply press it, highlight it, press Ctrl R, and here we have all the values in this test code. So we have this, well, you can see here the code that we are using to create the HTML, and this test code, we can see all the values here. So we can, with a quick glance, we can see that, okay, well, it can be a string, it can be an object, it can be an array. We can, look inside there. So what is inside this object and that object? Maybe we even notice that in this object we have this P, which actually does a P DOM element paragraph with some ID set there and some classes set there, and then it has this text in here, and then we have the same text here on the second time the transpile function is called. So what you can figure from here is that it's working iteratively. First it gets this object, then it goes through this object, and then on the second round it will send that value to the transpile function again. If we click the transpile function, we can see it happening here. You might also notice that before all the values in here, they were white, but now we have the color in them. So we can, with the color indicating the type, we can instantly see all the types available in here. Also, if we put the inspector, now it's inside the transpile function at this position, but if we put it in some different position, something different will happen. Actually, nothing happens, but as you can see here, the yellow spot is not bright. So when it's not bright, when it's like a dim, it means that this part of the code is never reached. So we are doing here stack depth check. So this is kind of to be sure that we don't end up in endless loops. If the depth of the stack will be 100, then we will throw error and stop iterating on it. So since the depth never reaches 100, we never end up in here and nothing changes. But let's put it in here. And this is part of the code that is reached. And you can also see some changes. So these values used to be, so when we put it here, these values are here defined, but if we go into this else if inside here, or rather here, these values become purple. So once we have this else if, and we end up in this part, so on the execution time that this inspector is called, it never reaches this part of the code, so it's unable to inspect any of these values. So we can also do this kind of jump around in the code, run the inspector, and kind of see this function in different states based on at which position or which line, which column we are looking into. Okay, kind of lot to digest here. So let's step up to the more simpler example. So typically when you do debugging in normal coding environments, you use either console or you can use debugger. So you start up the program in debugging mode, and then you can put breakpoints there and step through the code and see what's happening there. Well, you can't exactly do that. You can't step to the next slide and previous, but you can kind of do the same thing here as well. So let's do something a bit more complicated. So let's say we have this sum function, we call the sum function, and then inside the sum function we call the sum function 2. And let's not call it here. Except we can't do it because it's undefined. Well, we already see something that I'm about to show you. So now we have error here. Since the sum function 2 is defined after the sum function 1, it will give us an error, and here we can see the stack trace. So we can see that the execution of the code that ended up in this error starts in here with the smaller red dot, and it ends up in here where the actual error is thrown with the bigger red dot. Well, let's just throw this code below the second one. Now we don't have an error, but let's say I'm coding here and I would like to see, well, maybe here, I would like to see this value after the first time this for loop is executed. So basically I want to put a breakpoint in here to stop it here. So we don't have the breakpoint button here, but we have something similar. We can simply throw an error. So now, and let's do another thing. Let's throw the inspector inside this function just to be sure. So what we have here is we have the code executing. It will call some function from here, then it will call some function 2 from here, and once it reaches the error, it will, all the variables now that we inspect here should be in the state that they are after this function is called for the first time. So if we go here and say 3 times 1, we will see that it's 0. So since the iterative loop starts from 0 to 10, on the first time this function is called, it will be 0. So this is kind of like you can do similar debugging in here. So let's say I would have some other things here. So I would say 3 times, let's say even more is 2 times 3 times 1. So now once I have the error here, I can debug the code. Or once I put the inspector here, I can debug the code before the error. I can throw the error underneath this even more, and then I can see debug the even more as well. But I need to, now the thing that I need to do is I need to put the inspector above the error. Sometimes it's automatically if that's where I've been changing the code previously, but if it's not, I need to do the Control R to put it there. So now I see that even more is actually not even more, because it's 0 and 2 times 0 is also 0. But as you can see, you can step on the next lines like this. And maybe it doesn't feel quite as useful as a debugger, like the normal debugging, or the, how would I call it, the debugging environment in the debugger. But the upside in here is that we are not in debugging environment. If we do changes to the code, we are doing actual changes that will persist over reloads and over we will, yeah. I think this is getting a bit too long, so I'm kind of starting to not be quite so clean in what I'm explaining here. But let's take just a quick glance on the butterfly example again. So let's say I will be coding in here, and let's say I will say that y is star stiff, and we also again end up in error. So this is very useful when I'm doing something much more complicated. So maybe the error that I'm throwing here is not something that I don't quite understand, but since I'm immediately in the position where the error is thrown, I can inspect all the variables before the error happening. And this is something that can be very useful in understanding why this error is thrown. And I can also see from the dots here, I can see the stack trace. So instead of typically when you look at the stack trace, you will go here and you will kind of just see the code, parts of the code where it's coming. But in here, I will see it immediately, like directly in the code. So I will see that, well, we are calling the repeat function, so that's one part of the stack trace. You will call the wing function next part, then we will call the wing function. Another thing here to notice is that typically we have the small yellow inspector dot, but when we go here, we have it bigger and we have some number inside it. So this is another hint. It tells us something about what's happening in the code, and what it tells us is the times that this part of the code is being executed. So the bigger the number, the more execution times, more times the inspector is called at this point. And since when you doing coding, you can end up calling some part of the code very many times. So you can be, thousands, even millions times being called at a single spot. So if I would type here the whole number of the times being called, that wouldn't be it wouldn't fit here, and it wouldn't be even that useful, because we don't really need to know if it's called 100 times or 101 times, at least in this perspective, what we're trying to give here. What we want to do is we just want to give you some idea of how many times it's being called. So especially this is good when you think it in the terms of performance. So if you have some part of the code that is being called, let's say 1 million times, you need to be much more carefully thinking about what exactly is it that you're doing there. You need to be writing much more performant code than at some part that will be called only once during the whole execution of the program. So to give that glimpse for us, the number that you are seeing here is logarithmic, base 10 logarithmic of the times that it's being called. So if it's 1, that means that this part of the code is called about 10 times, 2 means about 100 times, 3 means about 1,000 times, and so on and so forth. So even if it would be called 1 billion times, we can still show some value in here. In billion, it's 9, right? I always get, or 6, actually it's 9, yeah, I think. Anyway, so if we have it here, we can see that this part of the code is being called about 100 times. If we go inside the second for loop, we will see that this part of the code is being called about 100 times. And yeah, we can also like inspect all the single values in here. But if we go here, I think what it will tell us is that there are too many. So it will inspect the first 500 times this called, but you know, if it will be inspecting, let's say 1 million times and printing all the values in here, it will get quite stucky. So it will stop at 500 and just tell you that there will be something more. But anyways, I think that concludes the part about inspecting, and yeah, I will make more tutorials to look other facets, I think that's the right word maybe, of this editor thing later. So until then, bye bye.